So in this infinite sequence, m is divided, or m is defined as, m1 equals 6, m2 is 96, etc., where each one is a term, every one of them is 10 to the k minus 4. Is every term divisible by q if q is an even number? Yikes. So really the main thing that we can do before we start tackling statements is decide that every number in this sequence looks like it's going to be divisible by both 2, because these are all even numbers. So so it's going to be divisible by 2 and by 6. Because this one's divisible by 6, this one's divisible by 6, and then it just looks like it's, they're all going to be powers of 10 minus 4, so they're all going to, it's just going to be more and more 9s ending in a 6 the bigger the number gets, and all of them will be divisible by 6. So we know it's divisible by 6. Is every one of these divisible by q if q is even? Well, that's two different numbers that are possible there. And we need to know more information before we can decide. Statement 1 tells us that q is less than 45. Well, there are a lot of numbers less than 45, even numbers less than 45, and not too many of them are 2 or 6. So, and any of them larger than 6 are not, let's see, how do I put this? Since the smallest number in the sequence is 6, no value for q larger than 6 works, because 6 isn't going to be divisible by 7 or 8 or 16 or anything. So basically we need to know, we only need to concentrate on numbers that are 6 and lower. Okay, but so q is less than 45, we still have a choice between 2 and 6 and the number like 4 in between it. So statement 1 is insufficient. It's not A and it's not D. Statement 2 tells us that at least 2 terms in the sequence are divisible by q. So luckily the problem gives us 3 numbers for the problem. We get 6, 96, and 996. We know that it's divisible by 2. We know that it's divisible by 6. And so we still need to figure out some of the other possibilities. Let's try 4. If we divide 996 by 4, it equals 224. 96 divided by 4 is 24. 6 divided by 4, though, is not evenly divisible. So here we have an example of a number for q where it's divisible, where it's evenly divisible, where 2 of the numbers are evenly divisible, but not all of them are. So if q is 4, it's still not sufficient. Whereas if q is 2 or 6, it is. So again, with sometimes, with sometimes yes, sometimes no, the statement is insufficient. So 2 on its own is not good enough. Even in conjunction, we still don't know what q is. If q is 2 or 6, then the answer is yes, every term in the sequence is divisible by q. If q equals 4, or 8 or something like that, then the answer is no. So again, with sometimes yes, sometimes no, then they're insufficient. So even together, the 2 statements are not sufficient. Answer choice E.